So, hi participants. Uh, we have our next session, which is a live session on data regression tool in DWSim. Now, before we get started with the session on how to do data interaction, how to do data regression to to find out binary interaction parameters. First, I just wanted to give a background on why we need this kind of a tool. Okay. So basically, what happens in not in DWSim only. I mean, in any simulation process is that it's not just the input data that matters in our simulation. Okay, our thermodynamic database or the thermophysical properties of the components that are available in the component database is also something which is very important to the simulation. So if we want to get a desired result, if we want to get a desired separation in the distillation column, if we want to get a desired separation in an absorption column, it is very important that we have correct thermodynamic data, thermophysical properties of that system available with us in the component database. Okay, now how do we say that what is available is correct or not? That is the first question, right? So generally what we do, we start with a simulation, and we know, I mean, we have we do have a kind of expectation that okay, if I perform simulation of a, if I perform distillation of a benzene and toluene system, I do expect 99% benzene at the top at the distillate, and then 99% of toluene at the bottom. So this is the kind of expectation I have when I want to perform, when I go for performing a benzene toluene simulation, distillation simulation, right? So likewise, whenever you are performing any kind of simulation, you do have kind of an expectation that okay, this is what I'm expecting the result. And when you don't get that expected result, that is when you go back and try to find out as to what is happening. I mean, is there something wrong input that I'm giving? That is the one check that you try to do. The second check is there something wrong with the chemical properties, with the component properties? Is my data, is there some missing data because of which I'm not getting the expected result, or because of which the flow sheet or the simulation is not getting converged? Okay, so you then think upon different possible reasons because of which you are not arriving at the expected result. All right. Now, one of the reason for not getting expected result in simulation, especially the separations, okay, especially in distillation separation or absorption column separation, is not having correct interaction parameters or not having interaction parameters at all. Okay, so sometimes what happens is that the system is smart enough to uh, give you the separation without even interaction parameters, but sometimes it says that there is some missing interaction parameter data, and therefore your system cannot be simulated. So now in that case, how do we go about uh, finding the missing interaction parameters, right? So hopefully all of you are aware of what an interaction parameter is, right? What is a binary interaction parameter? That I think all of you know, so I'm not going into that detail. Okay, but it is very important that the interaction parameter between two components needs to be determined to obtain the thermophysical properties of binary mixtures. Okay, and if you see, there has been a lot of work that has happened in this area, in the area of prediction of binary interaction parameters. Okay, by doing experiments, by performing simulation, by doing experiments, and then taking those experimental data to simulation and kind of try to find out how to what can be the interaction parameters. So what I'm going to demonstrate today is a kind of how do we use DWSim tool to find binary interaction parameter. Now, when I say this thing that how do you use DWSim to find binary interaction parameter, I mean, I'm not saying, or I'm not guaranteeing you that this is something that works every time, but this is one of the tool that is available. And sometime it might happen that your simulation doesn't have a binary interaction parameter, and if you can find out your binary interaction parameter through this tool, your simulation might work. Okay, so I'm just going to demonstrate you as to how to use that tool. Let me share my screen first. This is my DWSim window. Before I go to perform a simulation of give you a demo of the data regression, let me first show you where you can find the existing interaction parameters. Okay, how you can see the existing interaction parameter for a particular system. Okay, so the example that I thought I'll demonstrate to you is this benzene cyclopentane system. So let me first add these two compounds. benzene, cyclopentane. Okay, so I have added the two compounds, benzene and cyclopentane. Now what I'll do, I'll add a thermodynamic property package for that. Here I am adding Peng Robinson, and I click next, and then I finish. Okay, so if I have to now go and see as to where the binary interaction parameter for this benzene cyclopentane system is existing, what I'll do is I'll go back to the settings option, and let me adjust my window. Yes, so I have thermodynamics of Peng Robinson here. All right, and if I just click on the model option here, okay, I can see that there is a window coming up which says configure property package Peng Robinson, and the first option is a general option, the second one is an interaction parameter. Okay, now if I go to interaction parameter, if you see cyclopentane and benzene, the interaction parameter for cyclopentane and benzene is being displayed as 0. Okay, it's missing. So which means that currently the system doesn't have an interaction parameter for cyclopentane and benzene for a Peng Robinson property package. Now it might happen that when you are performing a simulation using this system, when you are trying to separate this particular system in a distillation column, the separation that you are expecting, you might achieve that even without an interaction parameter, and therefore we don't bother much in that case. But sometimes there are a lot of other components available along with this system of cyclopentane and benzene. All right, and in that case, when you are trying to separate the system, that time it might the separation might not happen, and then you might then you will have to give the binary interaction parameter and see that whether the separation is happening after that or not. That doesn't mean that if you just give the binary interaction parameter, your separation will happen, but that is one of the checks that you must do when the separation doesn't happen in the first case with the available data. All right, so what I'll do is I'll now close this, and now I'll go and let me go to file. Let me go for new data regression study. All right, so I'll go to this option called new data regression study, where this data regression study window opens, and I have this window. Now let me just give a title and description so that you understand. Benzene. I just gave a title and description to my sheet so that it's easy for you to understand it later. Okay, now what I'll do is let me select the compounds. Okay, so first compound is benzene. So from the list I can select benzene. Okay, and the second compound is cyclopentane. So let me click on cyclopentane. Let me find cyclopentane.
If you type, will it happen?
No, sir. I mean, we have to type really fast. Otherwise, that just
Okay.
yeah. Because if I type C, then compound starting with C will come, and then when I type Y, then the compound starting with Y comes. Okay. So here is cyclopentane. Now let me tell you one limitation in the current data regression tool in terms of compounds is that we cannot be having, I mean, we don't have the facility yet to perform data regression for a user-defined compound. So yesterday you have learned how to add a user-defined compound to your simulation, but even though you add a user-defined compound to your simulation, you cannot perform the data regression here because the compounds that are available here are only from ChemSep database. Okay, so I had requested Daniel actually that if he can make that feature available where we can also select a user-defined compound in this compound list. Okay, but he hasn't been able to do that successfully, but Daniel said that he's looking into it as to how to get it done. So, and he's hopeful that it will be get done soon. Okay, so probably sometime in one of the future updates of DWSim, we'll also be able to select a user defined compound. Okay. Now, when I do that, so then it asks me for a thermodynamic model as to what is the thermodynamic model for which I'm trying to find the interaction parameter. So you have basically these are the current these are the available thermodynamic models for which you can find the interaction parameter using this tool. So I'll let it be Peng Robinson. I want to find the interaction parameter for Peng Robinson. So I'll let it be like that. And then it just give me a kind of initial estimate. Okay, so these are the default values. I'll not do anything with this. Okay. Now the next point it asks me for is the experimental data, as to provide some experimental data for this benzene cyclopentane system. And if you see here, the first option is called type, where it asks for the envelope, PXY envelope, TXY envelope, TPXY envelope, and all of that. So probably then if you want to now find out the regression data, what will you have to do? You'll have to either you'll have to basically find out the experimental data for this. Okay, so here I do have a paper which was published in 1963 in Chemical Engineering Science. This is a paper by Hermsen, which talks about thermodynamic properties of benzene and cyclopentane system. Okay, and in this paper they have done some kind of experiment in the lab and all to find out this TXY PXY data. Okay, so let me just go to the data table here. So if you see, you have a data for you have the PXY data at different temperatures. You have a PXY data at 25 degrees Celsius, you have the PXY data at 35, you have the PXY data at 45. And this is the X, this is the Y, and this is the experimental P. Okay. So you have all these data points. So what we'll do is we'll copy this data point into our compound creator tool, and we'll try to perform the regression and find out as to if it is giving the correct result or not, or if it is giving any, if it is able to solve and find out the interaction parameter. Now, I can't, I mean, I couldn't be copying it directly from here. So what I've done is I have copy pasted all this and kept it here. Okay. I have done that in an Excel. So I'll just copy it from the Excel and paste it in this table. So let me first generate the required number of rows. Okay. Now X and Y is done. I have pasted my X and Y. Now, please remember the data that I'm trying to copy is a PXY data. Okay. So the T is something which I'll mention as 25 because the data that I took was 25. Okay. So the first T I'll mention is 25 and the other columns can be just left as it is or 0. And then we'll mention the P value. Okay. So all right. So now I have imported all the data from the paper to this data regression tool where I have given the PXY data. And please be careful with the units that you mention here. Okay. So you must ensure that the units are properly mentioned. Now, once you have imported your experimental data, then you go for this option. There is something called a search online VLE. This is something that I'll come a bit later. Okay. And then you have regression parameters. Okay. So what do you want to do? I mean, before you do perform a kind of regression, it's a kind of regression. So it will ask you that what is the method of regression and what is the objective function that you want to achieve and all of that. So here you have 4 different methods of regression available. Okay. Limited memory, truncated Newton, Nilder-Mead, simplex method, and IPOPT. So I'll first leave it as it is with the default method that is available, and we'll see if it is able to converge and give us the interaction parameter. So let us just click on this run regression button. Yes, so you see when I click on the run regression button, I had something in the regression result first. Okay, so it started with an initial, it started with the estimation, and in about 34 iterations, it was able to converge and give me the interaction parameter for the benzene cyclopentane system in Peng-Robinson model. So in your latest parameter, you can see that you see the Kij value here. So this is the interaction parameter for a benzene cyclopentane system. Now, once you have received this interaction parameter, what you can do is you can go back to your simulation. You can go back to your simulation, input the interaction parameter there, and then once again perform your simulation to see if it is able to predict the separation, if you are able to get the desired results in your simulation. So that's how you do a interaction parameter simulation in this tool. All right. Now, sometime it might happen that, let's say you tried with IPOPT and it didn't converge. Then you can just give it a try with some other method and see if it is converging with that or not. Okay. So if it doesn't converge, then you can try with the other method also. So let's say if I try with Neldermid, let's see if it is able to find the interaction parameter and give it to me or not. So it said starting experimental data regression, and the regression is happening. Okay, so if you see in the 8th iteration, it says maximum number of iteration reached. Okay, therefore it is not able to find out the regression parameter using Nelder-Mead method. But if I do it using IPOPT method, it is able to do that. It is able to find interaction parameter. Okay. Now, sometime it might happen that you are not able to find any paper for getting the VLE data. In that case, you can search in the online database, which is available with DWSIM, which is KDB. It's a Korean database called KDB Thermo database. If you just click on this, it might happen that it search for the PXY, TXY data that is available in the KDB database. If any data is existing, then it will give you some list here. If it doesn't exist, then you will get a blank space here like this, how you see here. Okay. So which means that you don't have any online database available for this particular component system. Therefore, you'll have to finally find out a paper which has got the experimental data and perform the regression and then do it. Okay. So that is the thing. Now let me perform simulation for a component system for which the online VLE data in the online database is existing. So let me do that. So what I'll do is I'll once again go for new data regression study, and the system which I want to simulate is 1,2-dichloroethane and N-heptane. Okay, so 1,2. One, two dichloro. Is that the one? Dichloroethane and N-heptane. Yes. Okay. So this was my initial compound 1,2-dichloroethane and N-heptane, and the appropriate property package or thermodynamic model for this system will be SRK. Okay. So I have selected SRK. Now let's say that I don't have the experimental data. So in that case, what do? I try to find the VLE data from an online database that is available here. So if I just click on that option called search online for VLE data at KDB Thermo database, it will start searching the online database. And as you can see now, here you can find 3 different data. Okay, isothermal PTXY data for N-heptane 1,2-dichloroethane at 323.15 Kelvin at 70 degrees Celsius at this data. Okay, so what I'll go for is I'll go for this particular one, 1,2-dichloroethane N-heptane data. Okay, and if I just click on load data, if I click on load data, it will say that it is trying to load the data, and now all the data that was available in the online database has been loaded here. Okay, so you can see that the database is loaded here from the online database. And again, after doing this, you can start the regression. Okay, so as I run the regression, you see it is performing all the iterations and trying to give me the binary interaction parameter for this particular system. Okay, so depending on the type of data set that you have, or depending on the type of system that you are simulating, you can select the type here, and then you can perform the regression and see if you're able to find a binary interaction parameter. Okay, so apart from VLE data, you can also have the LLE data, you can also have the SLE data and all of that. So this is how we perform data regression in a, this is how we find binary interaction parameter using the data regression tool in DWSIM. So you have any questions in this particular topic? Yes, Rivera. So what I'll do is You have asked for Excel file to try the regression. So probably I'll share a couple of data. I do have a couple of data. Let me compile them and just share with you so that so that you can also try this out. Okay. So maybe I'll do this sometime in the, during lunch break. I'll just share the Excel file with you.
Hello.
You can give it a try.
Hello. Yes, sir. So I'm Nikhil Bagul from DMC. I do have a question about it. For data regression. If suppose we are dealing with two solids which we have to separate by something as sublimation, so can we carry out its like the regression in this way? Like how should we carry it? Because the examples you showed right now were for liquids, but if we have two solids, then how can we do it?
If you have two solid. Okay, so
separation is by sublimation. Like we heat it and we recover the solids. Like there are no two liquids to separate. So it's a mixture.
Then what kind of, first of all, you have to determine that, what is the kind of equilibrium method that will be applicable. Like here, I was dealing with a vapor liquid equilibrium.
Okay.
So first of all, you have to find out that what is the kind of equilibrium method that will be applicable. So sublimation, which means that you go from solid to vapor, right? Directly.
Yes.
So I don't know if it is. Let me just check here if it is possible to have. No, so we can have a solid liquid equilibrium, but not solid vapor. Okay. So,
okay.
It's not possible to do solid vapor equilibrium. It is possible to perform a solid liquid equilibrium.
Okay.
So maybe currently for that sublimation process, it might not be possible. But yes, if you are going for something from solid to liquid, then it will be possible.
Okay.
So probably these are, this data regression is not a very easy task to do. I mean, the development of the tool, because it requires a lot of effort to find out the correct algorithm that will be work to find out the correct method actually that it will work out. That will work with solid vapor equilibrium. So maybe I'll inform this to Daniel that we had this workshop and somebody requested that if we can also perform solid vapor equilibrium data regression and find out the interaction parameter for it. Okay. So maybe he can come up with
I have an answer to people from DMCC. What's your name?
Sir, Nikhil Bagul.
Nikhil Bagul, yeah. So it is also possible that you can engage the services of Daniel. You can request Daniel that because he is working as an independent consultant.
Yes,
right?
Sir. Yes,
and
sir.
he's supported by activities such as this. So if you think that solid vapor equilibrium will be useful to you, you can ask him so that he can prioritize, and then you can also offer to pay him some amount for doing that. He will do that for you and then make it available as a part of DWSIM. Then you will benefit.
Okay. Sure.
That is probably the most effective way I would suggest, because he is an expert. Because imagine if you have to struggle for 1 month, all from 3-4 people trying to figure that out. Loss in productivity, your salaries, and so on. Just give it to him, and then he will, we'll be happy to connect him with you.
Sure, sir. I will consult with my senior for such project. I just have to talk to him first.
Yeah, even to model your plants, for example, if you need any help, because he knows the system inside out, because he's the one who created that.
Yes, sir.
Right?
Okay. Yes.
Just imagine if your productivity increases by 1%, what will happen?
Yes, sir. It would be much easier.
Yeah. It makes sense to talk to him. Okay?
Yes, sir. Okay.
Yeah.
Thank you, sir.
Yeah, Priyam, we can continue.
Yeah. So there are a few more questions. I'll take those. Someone asked about how to choose correct thermodynamic package, and I think we already shared this link day before yesterday during the first day session itself, as to in the DWSIM as to what should be the criteria to select the thermodynamic package. There is also something called as thermodynamic decision tree, which are available in lot of thermodynamic textbooks actually. Okay, you can refer those thermodynamic decision tree and kind of arrive at the what should be your thermodynamic model to perform simulation. Okay.
Priyam?
Yes, Professor Miguel. Please go ahead.
In what cases we must to change the values of the minimum value and maximum value of for the parameter k? Because in the two cases that you showed, that values were fixed and you not made change. So,
Priyam, that minimum and maximum values of minus 0.5 and plus 0.5.
Yes. In what cases we need?
Yeah, that's a question.
In what cases we must change that value?
Okay. Yes, I'll tell you. So basically, what happens is that let's say you perform if you want to perform for NRTL, okay, for NRTL model, then what happens is your minimum and maximum value is from minus 5,000 to plus 5,000. All right. Now, in that case, that's a very large range. Okay, and it might happen that your regression tool is not able to predict in that particular range. So then you can narrow down that range to something like you can go from minus 1,000 to 1,000 and see that if your interaction parameter is able to, if your tool is able to converge and give you an interaction parameter. Okay,
no,
so that's the range.
You change the values. You didn't show that you chose the default values.
Sir?
And plus 0.5.
Yeah.
But can you change the values? That is a question.
Yes, we can change the value, but if you change the value, that doesn't guarantee that the system will converge and give me the correct
that's it.
Interaction parameter. Yes, we can definitely change the value. That's not a problem. We can do that.
Thank you.
Yes. So the initial method or initial way to go about it is let's keep the initial bound that is available there, and let's see if my system is able to converge and give me a interaction parameter for the system or not. If it is not able to converge, then I try to decrease that limit slowly and see if the system is able to converge and give me the value. But yes, we can definitely play around with that maximum limit and minimum limit, the maximum bound and minimum bound value.
Thanks.
Yeah. So someone asked if it is possible to get the equation after doing the regression. Probably I haven't done that or I haven't explored that. So I'll check that and get back to you as to if it is possible to do that. Maybe one of you can post that question in the forum, so that what I can do is after the workshop I can check it out for you and see if the equations are available somewhere, and I'll give the link if it is available. Okay. I haven't really explored it. I haven't really look around for the equations after I have performed the regression. So I'll try that out and I'll let you know as to what I find out. Okay. And Funny had asked that can we have an option?
Before you go to Funny's question,
yes, sir.
You may want to point them to the user guide wherein all these things are defined. All right. Whether it's Robinson or whatever, I thought that DWSIM comes with an excellent guide, user guide.
Yes, sir. Yes, sir.
You can point to that. In fact, I had referred to it sometime.
Yes, sir. Yes.
Let me see if I can pull that out.
Sir, can I share my screen, or you want to?
If you have it, I also have it handy. If you have it handy also, it's fine. You can go ahead and do that.
Okay. So.
Because I used it in CL455.
Okay. This is my DWSIM tool. Now, if I go to the help option, under documentation, there is something called as user guide PDF. Okay. So if you just go to this user guide PDF, here you have the user guide for DWSIM. Okay. The latest one for version 6.4.3. Okay. And if you go to data regression, so in this user guide, basically, if you go to the chapter 4, which talks about methods and procedure, a lot of equations, thermodynamic equations that has been used in this particular software, DWSIM, it is available here.
See, in the old version, it was called tech_manual.pdf. This describes how to calculate properties. Maybe the new one, it is called something.
Sir.
Yeah.
User guide. So this is how you got that, or are you referring to something else? I mean, this is the one that you're talking about.
No,
right,
the version that I had
was
called Tech. Remember the old version on which I created spoken tutorials?
Oh, okay. Yes.
Tech_manual.pdf.
Yes, that was technical manual. Yes, he used to call the technical manual. Yes. So you can locate the user guide from here and then look into these equations. Let me. Yeah, I don't.
And also there was one called Unit Ops and Utilities Guide.pdf. Is it also there in the user guide? Because
so that all has been merged in the user guide now.
User guide, is it? Now one replaces both the old.
Yes, sir.
Okay.
Yes, sir.
Okay. So that is the answer. Even if you can't get the expression, one can go to the user guide and see the expression for NRTL, Peng-Robinson, SRK, whatever you want to do. And that is the expression that has been implemented. Okay. Because it is possible that you cannot see the equation directly. It is not in the equation form. It may be coded, right? So it may not be available, but you can find out from the user guide how it has been, what formula has been implemented, and hopefully you would have used the same symbol, kg or something, right? That's what I would suggest in case you cannot find that. Going through the user guide is going to be helpful. Yeah.
Yes, sir. So the next question was from Funny as to how we can choose multiple property packages for a simulation so that after the simulation from the tabulated values of respective property package, we can compare them. Okay. If you, Funny, I don't know if I've understood your question correctly, but if you are trying to say that you want to run a particular system using two different thermodynamic models at the same time, I don't think that is possible. So what you can do is first you can run with one particular thermodynamic system, then you can get the results tabulated, save them, and then again you have to change the thermodynamic package to something else, and then you run the simulation, you tabulate the results, and then you compare them. It is not possible to run a same simulation with two thermodynamic packages at the same time. However, if you are trying to see if you can work on multiple thermodynamic packages in the same simulation in different unit operations, that is certainly possible to do in DWSim. So whenever you are entering, I mean, in your object editor window, wherever you are entering your temperature value, pressure value, or the outlet temperature things and all of that, there's an option called property package settings. Property package settings, where you can change the property package. Change the property package as per the unit operation that you are using. Okay, so let's say in a certain separator, I was simulating a distillation column which had hydrogen, and therefore the cow seeder model was necessary to simulate that. Now once I have removed hydrogen from my simulation using my distillation column, the further operation there is no more hydrogen. So I can have an option to use some other thermodynamic model for the rest of the simulation, where I can select Peng-Robinson, or where I can select SRK, or where I can select NRTL as per my existing component system. Does that answer your question, Funny? Okay. So with that, I think this session this session on data regression tool has come to an end. So yes, sir, I think I agree that this is a good topic for spoken tutorial. We'll certainly come up with a tutorial on this. So maybe now we can all take a break for lunch and then come back at 2, because we have a very interesting talk by Professor R.K. Malik, who will be speaking to us on tips for building effective process plant simulation model using sequential modular simulators. Okay, so with that, I think we can now go for lunch and then come back after lunch exactly at 2. We'll get started with the talk at 2 p.m. Thank you all.